Quick chemistry, acids and bases. Let's get it. First things first, we need to identify what an acid and a base is. An acid, we're going to call a proton donor, whilst a base, we're going to call a proton acceptor. Proton in question being a H plus ion. When you have equations, you need to look for your conjugate pairs. These are going to be compounds that differ just by the addition or removal of a H plus ion. So look really carefully in your equations to find these. Something else we need to consider is the reactions of acids. We need to know how they react with metals, with carbonates, and with bases. Reactions should pop up on the screen now. We also need to be aware about definitions of monobasic, dibasic, and tribasic acids. Monobasic releases one proton in solution, such as hydrochloric acid. Dibasic, 2 protons, like sulfuric acid, and tribasic, 3 protons, such as phosphoric acid. Another important distinction we need to make is strong versus weak acids. A strong acid being one that fully dissociates in solution, releasing all of its protons, such as hydrochloric acid. A weak acid is one that partially dissociates, releasing some of its protons in solution. This can be, for example, carbonic acid. Now, when it comes to calculations of pH, we can use pH is equal to the minus log base 10 of the concentration of protons if we are working with a strong acid. Remembering that we need to multiply by 2 if it's a dibasic, multiply by 3 if it's a tribasic in terms of the concentration. When it comes to weak acids, we're going to use a formula that Ka is equal to concentration of proton multiplied by the concentration of the conjugate base divided by the concentration of the acid. When we're using that formula, we need to use some assumptions. So, we assume that the dissociation of the acid is negligible and that the concentrations of H plus and A minus are roughly similar. This will help with our calculation of pKa is equal to the minus log base 10 of Ka. Knowing that if we use our Ka formula, we can also calculate the protons and use the equation from earlier. With pKa, we'll see that a smaller pKa value leads to a stronger acid. And that's a wrap on quick chemistry. Thank you for listening, and we'll see you in the next one.